So if you were looking at me and I told you that my hair is black, you would take a look at it and say, yeah, that is true. And if you were looking at me and I told you that my t-shirt is red, it would check out and you would say, yeah, that is true too. But if I told you that my hair is white in your face while you were looking right at my black hair, you'd be like, no, that is not true. That's a false statement. And if I told you a similar thing about my t-shirt, saying that it's yellow, you would say that is also false. And it's easy to answer questions about whether statements are true or false when they are single statements like this, just one fact about one thing. But what if we try to join them together with conjunctions like and or or? If I told you that my hair is black and my t-shirt is red, you need to think a bit about whether the statement is true or not. This statement is true and this statement is also true. So if I say them together with and, it makes the whole thing true. And you'd be like, yeah. But if I told you that my hair is black and my t-shirt is yellow, you'd be like, wait a minute, no, it's not. It's red. And you would say that this statement is false. If I then told you that my hair is white and my t-shirt is red, you'd be like, yeah, this checks out, but my hair isn't white. And you'd be like, well, that's false. But if I told you two lies, that my hair is white and my t-shirt is yellow, you'd be like, you're not being reasonable anymore, and you would say this is false. So it seems that when I join two simple statements with an and, both of them have to be true for the whole statement to be true. If even one of them is false, then the whole statement becomes false. I can try the same exercise with or. I can see if I tell you that my hair is black or my t-shirt is red, you'd see this or, and it makes you think maybe just one of them needs to be true for the whole thing to be true. And I mean, right now, both of those statements are true, so you'd be like, yeah, that checks out. This is true. If I told you that my hair is black or my t-shirt is yellow, even though my t-shirt isn't yellow, my hair is black. So you'd be like, yeah, that statement is true. If I told you that my hair is white or my t-shirt is red, this still checks out, even though this is false. So you'd be like, yeah, one of them needs to be true because it's an or. So yeah, the statement is true. And if I told you that my hair is white or my hair is yellow, both of them are false. There is no truth in the statement. So you'd be like, yeah, this is false. And let's use a different color, because we have been using green for false. So it seems that when I am using and to join two statements, both of them need to be true for the whole statement to be true. But if I'm using an or, both of them need to be false for the whole thing to be false. And we can kind of make a table out of this. We can, instead of using true and false, we can use zeros and ones because that's quicker to write. And instead of writing down whole statements like this, we're going to write down A and B. Instead of saying my hair is black, I'm just going to say A. Instead of saying my t-shirt is red, I'm just going to say B. And I'm going to ask you, is B true or false? So let's try to tabulate all of this information that we just got. Let's write down A, B, A and B, A or B. And let's write down all possibilities for A and B. We can have either both of them to be false, which we'll write down with a 0. We can have A to be false and B to be true, which we'll write down with a 1. We can have A to be true and B to be false, or we can have both of those statements to be true. And like we saw, if both A and B are going to be false, then A and B is false. For this column, we can see that both of these statements are false, and like we saw, that makes the whole statement false. If one of them is true and the other is false, then when you join them with an AND, that makes the whole statement false. But for OR, it makes the statement true, because either of them have to be true for the whole statement to be true. I can do the same thing here. If one of them is true, then if either one of them is false, then the whole statement is false. And if either one of them is true, then the whole statement is true, in case of AND and OR respectively. And if both of those statements are true, then irrespective of what conjunction you're using, the whole thing is going to be true. So you can see we have this little table here to refer to. And why would we refer this is something actually we didn't talk about not. If I told you that my hair is black, that would again be true. But if I said my hair is not black, that would be false. This is another operator that we use quite often in maths, and we should probably add this to the table. And if I did, we can make two more columns maybe. One for not A and not B, right? Not A, not B. And so if A is ever false, not A would be true. If A is ever false, not A would be true. If A is true, not A would be false. If A is true, not A would be false. Same for B. If B was true, it would be false. If it was false, B would be true. If it was true, B would be false. If it was false, B would be true. And if it was true, B would be false. And so that was not A and not B would look like. And we're going to use this table soon.